So info objects are the basis for the definition of any other data target. To create any data target from info cube or data store object or anything in a BW system, you have to create info objects which are building blocks for them. So generally there are two types of info objects. Mainly there are key figures and characteristics. Info objects are defined by a system-wide distinction, technical name, like you have zero customer. This is zero customer is a naming convention for the SAP given info objects. If you want to create a info object, that means a user defined info object should be followed by a naming convention A to Z. It should be Z customer or Y customer, depending on the naming convention your company is following. So when the metadata of the info object is activated, BW automatically creates data element and the domain and SID, SID table, all this table, master data table, all these tables will be activated. So generally a characteristic is a descriptive or categorizing information, and a key figure can be used for calculations. Key figure is summarizable. It means cumulative. Key figures are cumulative generally. When there is a non-cumulative key figure, you have to set the option for the non-cumulative key figure, because they have a special detail. Generally key figures are cumulative. So detailing information stored as a detail level for drill down for the characteristics, and the information that is aggregated to characteristic is key figures. It means characteristics are defined for the key figures, and key figures are aggregated according to the characteristics. So this is the naming convention here, and the technical name, length of the technical name of the characteristic and key figures are up to 9. You can define up to 9 length of technical name. You cannot define more than 9 length. And you can see the data element here. It is a /bi0 capital O capital I. It is not 0 here. It is a bit confused, but it is not 0 here. So /bic for user defines, capital O capital I, A to Z TTT. So this is the data element. We use this table. This is very important. We use this table while we are defining routines, and we use this table if we are doing lookups from, for example, when you are when you are transferring the data to the target, and you want the data which is not available in the source, and you want to do the lookup on some other target, some other object. In that case you use lookups. So for that purpose, for coding purpose, you have to get this table name. So descriptions are 20 characters for short, and 40 for medium, and 60 for long. This is the standard for the descriptions in BW. So there are 4 types of info objects mainly. It is running, right? Hello guys. Hello.
Yes, it is.
Yeah, so there are 4 types of info objects: characteristics, times, units, key figures. Every info object contains a data element. So when you activate an info object, a SID table will be created. Because of the SID table itself, we are able to use one info object to more than one data targets, because SID table is the reference number which we are using. In BW system represents a characteristic not with its own value, but with the SID reference, SID table, which is a 4-byte key, and it is a reference. So you can use the same info object in 100 objects or 200 objects, because it is possible only because of the SID concept. SIDs are called surrogate IDs. So there are options like lowercase and conversion routines. Let's see how to create info objects here. In order to create info objects, you have to create info areas which act as a folders. They are not exactly folders, but in means in the in BW terms it acts as a folder. So you can give up to 32 technical name for the info areas, and info areas are used to organize the info objects as well as data targets. Let's say by giving the technical name and the description, I just have created a info area. You have to go to the info objects in the modeling and right click on the info objects. When you right click on the info objects, you get create info area. You have to give the technical name and description, and then continue with that. So your info area will be available here. In order to create a info object, you have to create info object catalogs first. You right click on the info object info area and create a info object catalog. So you have to give the technical name of the info object catalog and the description, and further you have to select whether you are going to create characteristics catalog or key figures catalog, because they differentiate. Characteristic catalog is used to organize and create characteristics only, and key figure catalogs are used to organize and create key figure info objects only. Once you create this, you just have to check and activate. Now you can right click on the catalog and create info object. So here we are into the initial screen of the customer. So here you have a data element which is already created for the customer. Before activating it is created, and the mandatory things you have to give in order to create a characteristic is data type and length. These are the two mandatory things. Without describing these, you cannot create characteristic. So you have to give the data type and the length. Here I am going to give overview of all the tabs available. This is the general tab. Here you have a lowercase letters, conversion routine, alpha, and attribute only. So if you check attribute only to this character, then this character will be only used as an attribute to another character, but it cannot be used individually, and it cannot be used as navigation, it cannot be used individually for and navigation purposes. So in order to create individual characteristic, you have to uncheck the attribute only. So here we can check the lowercase. So this is the Business Explorer tab. Here you can give the predefined settings if you want, but you don't have to give the predefined settings, because you can give the same settings in query properties. So it is available in Bex query properties. All these properties are available there, so you don't have to give it here. So we don't normally give it, describe them here. This tab is for master data or text. You have to decide whether you want to load the master data for the characteristic or not. Once you decided that you are going to load, or you may load master data, you have to check the fields which you want to do. For example, you normally check with master data for the attributes. It means you can load attributes with this option, and here there is a with text is available. It means if you check this, you and it means that you are ready to load the text for the master data. So for the text, there are further fields to be described. Here there are three options: either you want the short text, or medium length, or long text. It makes sense to load medium text or long text if the source system is providing the data. For example, for the customer, if source system is providing data in the long text, if they are giving some description about the customer, then you want to load the data to the BW, then only you can check long text. When you check these fields, system will automatically create these fields for the structure. So before checking this, if you have such a requirement, you have to check this, or else it will it doesn't make sense. So further, you need to describe whether texts are language dependent or texts are time dependent. You check by default it is available, language dependence is available, and it makes sense to load language if the source system is providing data in different languages, so that a language dependent will be used. And texts are time dependent means it creates further time variant, so that it can store the time dependent data. So that is the use of this. So what system will do is to here, according to this selection, system will create a field for the short text and a field for the language dependent. So 0 langu is the characteristic for this, and the short text 0 shtxt is the characteristic for this. Those two characteristics will be created by the system. And this tab is hierarchies. If you are going to load hierarchies for the material or customer for this object, you have to check this with hierarchies. If you check with hierarchies, all these options will be activated. Here hierarchies are there are options like hierarchies are version dependent, hierarchies are not time dependent, entire hierarchy is time dependent, and time dependent hierarchy structure. Generally hierarchies are grouped structures. So in hierarchies you can if you have an organization structure which you want to group it according to the according to the characteristics. For example, you have some nodes, levels, and you have some characteristics like continents, countries, regions, cities, like that. So you want to group the data according to that. In that case, you can create hierarchies. So there are hierarchy not time dependent. It means that you create hierarchy, and that hierarchy is a static constant. It means it doesn't depends on the time. For example, if there is a person working, a manager working in a particular place in a organization, and if in case we are representing him in the hierarchy. For example, he is in New York, and then he has shifted to the Virginia. So it has to show, for example, the duration. He was working in New York from 2000 to 2008, and he shifted, he just transferred to the Virginia from 2008 to 2013. So these durations, when give these durations, that time, because of those time limits, the hierarchy we have to use for that is a time dependent hierarchy structure. If if you want to click entire hierarchy is time dependent, what will happen is, the hierarchy, generally the hierarchy concept is, hierarchies have the root node and then the nodes, all the other nodes. So in that case, so generally hierarchy consists of a root node, and these are all called nodes. So in this case, when the system, when you define a hierarchy is time dependent, it has to be it will be dealing with the nodes. Nodes, all the nodes should be time dependent. And if the, in case, in our example, a person has worked in New York from 2000 to 2008, it will be a separate record. And then if the person is shifted from New York to some Virginia, so it will be the record will be shifted. That person will be representing Virginia from 2008 to 2013. So these two records in a same hierarchy will be created. That is called hierarchy, time dependent hierarchy. If you make it entire hierarchy as a time dependent, then the root node itself will be time dependent. It means that all those dates we apply from 2000 to 2013, and 2000 to 2008, and 2008 to 13 are applied here, and two hierarchies will be created according to the times. It will create two different hierarchies rather than creating two records. So that is the entire hierarchy time dependent, and hierarchy is time dependent. That is the difference between them. So here are few master data tables. You can see that there is a P table. Generally it is a time constant table, and when we are doing the routines, we can use this P table generally. And you can see for the time dependent master data, there is a Q table created. System creates this table. So if we are doing if we are dealing with the time dependent master data and we want to write a code on that, then we use Q table here. So there is a master data table view which is all normally created, that is represented by M. So generally when you system doesn't access directly the P and Q tables, but the view, and it accesses these two tables through view. So this table is also created. So master data SID time constant navigation table is there. For navigation table time constant attributes, the X table is created, and for the time constant navigation, time dependent navigation table, Y table is created. So you can see the results here for a clear picture. For the attributes, you have the result here with the attributes like name and phone and address. For the text, you will have a result like this. A system will generate a language key and the short description. For as default, we have seen these two checked in the here in this screen. We have seen this with text and with language dependent, short and language dependent. So these two fields will be created and it will be loaded like this. So you have for text, the table will be created by the system, that will be the T table, and for the hierarchies hash table will be created, which I haven't given. So generally lowercase letters is another option which is available in info objects. If you check lowercase, then it means that you are accepting lowercase. You have to make a choice before selecting lowercase letters, because if the business is if the business is representing the capital L and small l, like the same characters, uh, for example any model of a car, if you are loading a models of a car, and there is some cx, and if the capital C and capital X is there, capital C and small x is there, if they are two different, if they are giving two different meanings, it means we have to check the we should not check the lowercase letters, because we have to check the lowercase letters, sorry, because we have to load two of them differently. If you are loading, then it means that it will. So let's see here. In characteristic info objects, a customer number could be displayed as capital A and capital small a. So it should be clarified whether these two are identical or different customers. If lower cases are allowed, these two customer numbers will be stored in different forms, else we will get an error. So either we load both of them, or we will get an error. So that is why we have to make a choice before checking the lowercase, whether they both of them are two different ones, or we just want capital letters. So if you uncheck this, if you are still loading lowercase, that means the system will throw an error. So there is a conversion routine alpha, which helps you to convert from external formats to the internal formats. So for example, you will have a time field like this. Generally you will see the time fields in a year, month and day format. This is called internal format. And when you load the data and when you display the result, system will convert the time to the external format, which is for this conversion we have a conversion routine called alpha conversion routine. And not only this is for the dates, and for example, if you have 1000 as a organization number, and you have a you have to decide both of them are equal or both of them are different. For example, if you have you have those leading zeros, right? So that is the reason behind applying alpha routine, so that this is the external format and this will be the internal format, and it has to be this has to be converted to this format when the length of the character is 7. So length of the character is 7. So it will, what it will do is to convert the 1000 to the 000,000. Generally, if not, this 2 can even be identified as separate integers. So there is a compounding. Here you will see the compounding tab. You have attributes. Here in attributes you can define the other characteristics to make it master data, and to give attributes to the characteristic. Just as we have seen the master data load, here we have this other 3 characteristics given to the customer identity, and all these characteristics are displayed when you load the data to the characteristic z cust id. So here we are just seeing maintaining the data in a customer id, and we are getting all the descriptions of the customer id in a as a different objects. So all because of giving them in the attributes, because we have described them in the attributes, we are getting this related information there. So this is where we describe it. So there is a tab called there is another one. If once you describe this, you can make attribute as a navigation attribute, which derives the characteristic to characteristic relationship, and it will in query it will act as an independent characteristic. So generally attributes cannot be used separately. They can always be used with the master data characteristic. But here if you check it as a navigation attribute for the attribute given here, then the characteristic can be used separately, just like it will be treated as a separate characteristic in query. So we have compounding here, but compounding is used in order to make the define a characteristic as a uniquely identifiable. So by giving the superior info object, you will be defining the customer number a uniquely identifiable. For example, for example, you have a partner roles or something like that in sales. You can make it unique by giving some other characteristics. So there is another example. You have a same characteristic in different source systems. So you want to identify so for example, you have SAP system, non-SAP system, and other BI systems connected to the same BI systems. You can connect other BI systems to BI systems as well. So it can be BI to BI, or SAP to BI, or non-SAP to BI. So you can have the same characteristic in different source systems. So once you have the same characteristic in different source systems, for example, you want to identify it only from the ECC data. So what you will do is you will use the zero source system. This is the characteristic, and you will use it here, and you will by using this, you are storing the source system information here, so that this characteristic can be related to this source system, and hold together this is making a uniquely identifiable. So this is uniquely identifiable here by giving the source system ID. Okay. No. So that is about the characteristic. All the tabs of the characteristic available in the characteristic. So we have here characteristics here. You can see we have defined attributes here. for the characteristic. Here you haven't seen the green symbol here, so it means that hierarchies are not activated, attributes are activated, and master data is activated. So that's how you create a characteristic. And there are time characteristics which are supplied by the SAP. If you create time characteristic, a user defined time characteristic, then you can use them, but you cannot give the automatic transformation which SAP characteristics can do. For example, you have a 0 cal day here, 0 cal day in the source. And you have so these are standard ones. You have 0 calculator here, so you have in transformation you have mapped 0 cal day to 0 calculator, and then in that case the system will take cal day and system will provide calculators from the cal day. It will derive automatically for us in transformation. If this is z cal day, it means user defined characteristic. In this case, system will not do the automatic transformation of the dates. So we have to decide whether we are using it for automatic transformations or not. So if we need for the automatic transformations, and we want to use the options that provided by the SAP, we have to go with the standard time characteristics as given here. So key figures are meant to be added to the fact table of the star schema. For example, key figures are summable and they make mathematic operations. So for that purpose we use key figures. When you create the key figure, you have 3 tabs in the key figure. Mainly you have to define the unit or currency, and either it is a data type, amount, or quantity, or number, integer. You have to define the data type and the currency for the key figure. These two are mandatory, and once you define as amount, you have to give 0 currency for the unit. If you define the quantity, you have to give 0 unit as the unit. So in aggregation tab you can use exception aggregation. Exception aggregations are they are used to calculate in analytical engine. So these calculations can refer to a deeper level of detail than in the analysis tool. You have an exception aggregation option in queries, so you can use exception aggregation in queries as well. But if you use it here, if you use it while modeling the key figure, and you can give the characteristic here for the reference. By using the exception aggregation here, you will be doing the calculations in the analytical engine in BW, so that it won't be the burden on analysis, and the performance will be better there. So info cubes are mainly consist of a fact table and dimension tables. Info cubes are built according to the snowflake schema. Here we will create an info cube. So while creating an info cube, you have an option. You can even copy info cube from other info cube, or you can create your own info cube. And you have either it is standard info cube, or either it is based on DTP for direct access is another option, and either it is based on the BAPIs or function modules. These are called remote cubes. When it is based on the BAPIs or function modules, the structure and the data will be provided to the info cube from uh, ABAP program. So what you will do is to create an ABAP program to match with the structure of the info cube and to supply the data to the info cube. So these are directly feeded from ECC, and it is not suggestible for large amount of data. So these two here with based on DTP for direct access and the standard info cube, these two variants are physical info providers, physical info cubes. And these on based on BAPI on function module and real time are virtual info providers. You have to create and we have, yeah, we don't have material number, right? For example, we can borrow material number from that one. We can create the info cube here. You can see in info cube by default system has 3 dimensions created. Business programming interface, BAPIs or function modules, they are programs to feed the data and to there are programs we create in ABAP language. In info cube there are 3 dimensions. You're welcome. There are 3 dimensions. One is data package, one is time, one is unit. These 3 dimensions are created by SAP, and these are SAP created dimensions, and you will find these 3 dimensions in every info cube. Generally the limit for creating dimensions in info cube are 16. Within 16 dimensions, 3 dimensions are SAP created dimensions, data package and time and unit. Here in data package you have few records like change ID, record type and request ID. It means that the request, when you load the data is loaded via request, so that every request has a request ID. The request ID is stored here. It means the info cube stores data according to the request IDs, so it can separate the data according to request IDs. And in time dimensions, as I said, if you are creating a standard time dimensions, you can input it directly from here. If you are not using standard time dimension characteristics, you cannot. Here you can see these are standard characteristics. We haven't created anything. These are SAP given time characteristics. So 0 cal days, 0 fiscal period, 0 fiscal year, fiscal variant, all these are standard info objects from SAP. So in a given time dimension here, which is standard, we can only add standard time dimensions, time characteristics. We cannot add user created time characteristics in this dimension. In unit dimension you have 0 unit and 0 currency values here. When you load the data for the key figures, you need to load with the currency details, units. I'll show you that. So here you can see this. Here in this one there is 0 cal day, but generally the date fields created by user, that date fields are not added to the standard dimension, they are added separately. And you can see that 0 currency is available in the unit dimension, because in characteristics we have z material cost. So for this material cost, we have to, the source system has to pass the currency for the material cost. For that purpose there is a 0 currency which is automatically created. When you see the transformation, you will know that. For example, this transformation here, it has bill amount, and one rule is coming from the bill amount and another rule which is coming from the currency. And here you have a quantity, it has two rules, one is coming from the unit and another rule coming from the quantity, material quantity. So when the system maps, it will map automatically. If that doesn't maps, we have to manually map it to the key figures. So in order to so for dimension 1 you can do the customer dimension. Here the customer dimension, for example, I am giving the description, and generally the descriptions are given in order to make the characteristics, in order to group the characteristics according to the dimension. For example, if I have created customer dimension, I will only give the characteristics which are related to the customer in this dimension. I will not give more than that. But here I am checking the line item dimension, because when you check a line item dimension, you cannot create more than one, you cannot give more than one info object. And I am okay with that, because we have loaded master data for the customer. And what I will do is to add the customer info object here, and I can use all the attributes of the customer in drill down of the query. So we don't have to load all the data, all the attributes here. So there are two options, line item dimension and high cardinality. When you use line item dimensions, you have to use only one info object. The concept behind that is when you are using line item dimensions, the dimension IDs won't be stored in the fact table. Generally the dimension IDs are stored in the fact table. Instead of storing the dimension IDs, the system will store SID of a characteristic which we provide there directly in the fact table. By doing that, we are cutting the dimension IDs, and performance will be better. So if the dimension table disposes of lot of data records, it means if the dimension table has you can estimate the dimension table is more than 20% of the fact table. In that case, you have to check the dimension as high cardinality. If you check that as a high cardinality, the system will use the B tree indexing. So indexing change will be it will help the performance better. So let's create an info cube directly. So we are checking line item dimension for that reason, and in this we are using a characteristic info object which we have created. You have to drag it and drop it here, and you got characteristic info object. Now I will create another dimension for the materials. And what I will do is to right click on the technical name of the dimension and info object direct input. So here we are loading material number as well. So for the key figures we have to load data, and for now we can borrow the key figures as well. Here you have to copy them. Here right click on the key figures tab and do the direct update, direct input of info objects. You can paste it here. Okay. So these are the 4 key figures I have given, and when you enter you will get all the all the descriptions here. That means it is all accepted, and when you continue they are all given here. So here with this our modeling of info cube is completed. After modeling you have to check the info cube, and then when it is displayed that it is consistent you have to activate it. So here you will see all the messages here for everything which is created in the process of activation of InfoCube, and at the end InfoCube is activated. So we can go back. Here our InfoCube is activated, and I mean up to now the InfoCube is activated there. So for the data store objects there are 3 kinds of data store objects. Data store objects contains consolidated, cleaned up item level data, and very granular data will be stored in the data store objects. So generally they are basically flat structures which group characteristics and key figures in a table. So BW offers three kinds of data store objects. One is direct update DSO, write optimized DSO, standard DSO. Previously in 3.0 version, there are only write optimized DSO and standard DSOs, and they too were called as transactional ODS, operational data source. ODS means. So when you create a data store object, let's see how to create a data store object. You have to right click on the info area and create a data store object. Here you can see in the settings tab you have a type of data store object. When you click this symbol, you have three types of data store objects available. You have to decide which one you want, either standard data store object, direct update data store object, or write optimized data store object. What is the difference? We are going to discuss it now. So the least one is direct update data store object. Here there are very fewer functionalities. It supports very few functionalities. So what is the difference is, generally we don't have any staging functions in direct update DSOs. It means it doesn't it's not used for the data acquisition from the PSA. You cannot get the data from the PSA. What it is used for is to get the data from analytical process designer, APDs. So generally APDs are created to APDs can execute are can be executed to get the query data, and it can write the data to the direct update DSO. Direct update DSOs always overwrite. You cannot add up the data. So it will only be overwritten. Data will only be overwritten in the DDSOs, and you cannot use it as a source. It can only be the target. So in that case, what you will do is to get the data from queries from the APDs. For case we use direct update DSOs, it will have only one table. So generally it doesn't normally have more use in BW, and you cannot use them for reporting purposes. So write optimized DSO on the other hand have one table, which is active data table. What are tables? I will explain you now. Before going to the write optimized, we will discuss the standard DSO. Standard DSO has three tables. Standard DSO consists of three tables. So standard DSO consists of three tables: one new data table, active data table, and change log table. In new data table, when the DSO is not activated, standard DSOs need activation before the data is available. Until you activate the standard DSOs, It is a separate process to activate the DSO. Until you activate the DSO, the data loaded to the DSO is not available for the reporting. So until then, the data resides in new data table, and then after activation, the data will be changed to transferred to active data table, and then the calculations will be noted in the change log table. For example, you have a record, say you have a sales key figure, and you have a you have 50 for the sales key figure, and you have loaded it to the DSO. And in that case, standard DSO will the active data table will have 50 in there, and then you have the change log table will store 50 as well. And then what you have done is to load the delta. In that case, in delta you have 30, and you have loaded the sales object with the 30 key figure with the 30. And what we'll have is, for example, we have summation, and for the summation you will have, after the activation, you will have 80 as the result. You will only have one record. Here you will have three records, 30 and 80. Here these three records will be created in change log table. So in change log table, basically there are changes, and there are, record mode as well. Record mode we will discuss later. So in change log table, basically there are changes noted, and in active data table, basically the activated data will be there in active data table. So that is the purpose of three tables. And basically in a, so this is the standard. So basically in a DSO there are key fields and data fields and navigation attributes. You don't see key figures folder here, because all the key figures will be given to the data fields, all the characteristics and key figures as well given to the data fields. And the key fields, other than key fields are used to store primary keys. For example, the primary identifiers, for example the customer ID. If we are loading here, we have to give it the customer ID here. I don't remember that. We have to give the customer ID in key fields, and then whichever are not unique, we can give everything else in the data fields. One is mandatory, and 16 we can load up to 16 characteristics in a key fields. So let's see what else to give here. Let's give some here. For example, we want some material number. Here you can right click on the data fields and do direct input. I'm giving additional fields here in the data fields. This is the character, material number, and there is a, and I'm giving some key figures as well. So here I have given one characteristic and few key figures, and when I enter, it will take the definition of all those objects, and we can continue. Here by doing that we have created a DSO. We have given a customer ID and we have given everything else here. You can see the 0 currency and 0 units are also taken, and they are taken by the system automatically because of the key figures we are storing. So you just have to check it, and when you see the consistent, you have to activate it. You can see reading metadata here. Metadata is where data is stored, everything is stored, all the related information. So there is, for example, fields that are from operational point of view dependent on the key fields are referred to as data fields. Generally, the key fields are the primary keys, and uh, and data fields are the fields which are dependent on the key fields, and only characteristics can be used as a key fields. The maximum number of key fields per DSO is 16. The length of the key fields may not exceed 780 bytes in total, whereas in data fields you can load up to 749 data fields. The maximum of 749 fields can be defined in data fields. You can define both characteristics and key figures can as a data field, and the maximum data record length of the data store table including key fields may not exceed up to 1918 bytes. So that is about the data store objects for standard, and we have write optimized DSOs. In write optimized DSOs, we have only one table, that is active data table. You don't have a new data table and you don't have a change log table in write optimized DSO. So they are only, they are very flexible. So for that purpose, SAP has recommended write optimized DSOs to use it as a layer between the data source and the InfoCube, so that we can have the snapshot of the data in write optimized DSO. Once you load the data, you can load it to the cube for the maintenance purpose. For example, if we delete the data in the cube, and generally we delete monthly data monthly in the PSA. So in that case, if we want the data, we will have the data in an intermediate stage, which is write optimized DSO. So generally the data is loaded according to the unique key which is generated by the system. and you don't have to activate the data in right optimized DSO, so that you don't get SIDs generation as well. So it is very easy to load the data, and uh, it is only for the to keep the snapshot. So you can, however, do reporting on right optimized DSO, but in that case the SID values will be generated when the BEX report will be is executing. So while executing the report, SID values will be generated, and for that purpose it is not good for performance reasons. So it is only used as a consolidation layer, because delta creation is not possible with this type of DSOs. It will store the granular data, normalize it. So it don't I mean if you want to do the delta process, you have to use standard DSOs further after the rate optimized DSO. So here it is created, activated successfully. And we go back. Here we have created a DSO, we have created a cube. So I guess so. Virtual providers, we will see when we are creating a virtual providers practically. Along with that, we'll explain virtual providers. And master data we have seen while we are doing this, and I will give this document. So we have to see transformations and DTs which I have created now, and we may see later. Do you guys have time now? Can you answer?
I was mute, so it took me like a minute or two to answer, but I have time.
Okay. So what about Adi? Are you there?
Is he-
He's not there.
I guess he's not there.
Okay, so do we look at this now or later?
Let me text him and see, because since we're doing the sessions together, I don't want you to have to repeat yourself.
Yeah.
Let me find his cell number. Yeah, that way that'll just prevent you from having to repeat the same thing.
Yeah.
I just text him, so hopefully he'll respond shortly.
Okay. So let's quickly see the reporting so that you can while you are practicing, right, so you can see reporting tool as well. Here if you want to go to the BEX, right, the navigation for the BEX is go to start and go to programs and go to BEX Explorer. Here you have analyzer and query designer. So generally I will show you how to go to the query designer. Here you have the same credentials once you give the password, you will get the screen for the Bex Query Designer. Here you will see the screen which is filters and rows or columns. Here in this filters you have default values and characteristics. I will explain to you later everything, every part of this. Now I want to show you so that when you are practicing you can get familiar with this. And this is a create. You can create the query by clicking this. So you, by going to the info areas,
Okay, he said he's still here, so I guess there's no sound on his end, maybe.
okay, that's not a problem. You can see that there are customer identity and all this. Here we have created these. Do you remember we have loaded the data for the customer identity, customer number,
Yeah.
characteristic? It is
Yes.
showing as a cube, but it is a characteristic. So we can double click on that and it will get the customer attributes there and the identity as a key part. So you can only drag and drop the characteristics to the rows and key figures to the columns. You can either drag column characteristics to the columns as well. It depends on the special situations. Generally we drag and drop the characteristics to the rows and key figures to the columns. Here we are taking all of this. I'm showing you a simple query so you can get familiar with this. And here you have a technical name to give. Generally the naming convention for the technical name is it generally follows with the info provider name of the info provider. For example, if it is zcustid, name of the info provider underscore the query name q0001, like that. So this one, it follows with the info provider name and the query name. Just a minute.
Okay.
I guess I'm erring in that. No, I can't. So this is the general pattern. So here I am giving the description and I will give the Z, which is name of the info provider underscore q0001. This is the naming convention for the queries, and you save it by giving that naming convention. Once you save it, you have to click this button to execute in query designer. And in order for that to work, they have to set the URL which they haven't set for this system, so it doesn't work here. So you don't have to panic, you just have to save the query and get out. And I will show you how to execute how to get into the analyzer. You have to go from programs, start programs, use analyzer, Bex analyzer. I normally use Bex analyzer. This is one way to use Bex analyzer. And from transaction transaction RRMX, you can directly use from BW. Here once you created the query, you can use it in open, or here you can go to the tools and create a new query. So you can create a new query or open here. So as we have created a query there, we will open the query, same credentials as BW. Bex Analyzer is nothing but a Excel with the Bex add-on. You can see here Bex add-on, Bex Analyzer here. Other than that, it is just a Microsoft Excel. We just created a query for the customer identity here. So what we will do is to open that query here. So you can see the result here. So this is the result of the query we have. These are the fields we have. So as you see the result, you can see the field for separate row for each and every characteristics is there. So if you want to suppress that, you have to right click on that and go to properties, and you have separate result rows. You say always okay, and one is suppressed, and go to this characteristic, go to properties, say always okay. So this one is suppressed, go to properties again, say always. So now you can see the result directly. So this is the data we have in customer identity characteristic, which we see it in Bex query. You can close here, say no. So now you can so another way to access the Bex Analyzer directory is to go to the BI system, and in search bar you can write the RRMX, which is a transaction for to access Bex Analyzer directly. Now you are directly into the Bex Analyzer. Here you can go to open, or you can go to tools and create new query. So other
What was
functions,
that, Trev? You said RMXS?
double RMX, RRMX.
Okay.
So here you go to the tools and create new query, or if you already have created a query, you go to the open and create an open query. So that's it for now. You can practice, and if you have doubts, you can definitely ping me anytime, and you can see the query designer as well. I haven't created my document completely for the query designer and for this one as well. So what I will do is I will still share with you the document, so that till here you can till the basic functionalities you can get familiar with, and in previous documents it is there, but you won't it is very lengthy, and by this one it is very easy to understand. So I am sharing this document with you.